What makes time reflections an example of unusual physics? Have you ever thought about how time and waves interact in ways that seem impossible? Time reflections are a fascinating example of unusual physics that flips our understanding of how waves behave. So, what exactly makes these reflections so strange? Time reflections occur when waves change direction, not in space, but in time. This is different from a typical reflection, where a wave bounces off a surface and continues forward in time. In time reflections, the entire medium through which the wave travels suddenly changes its properties everywhere at once. This sudden shift creates a unique situation where part of the wave can travel backward in time. Imagine this: the trailing edge of a wave becomes the leading edge after the time reflection. It is like an echo where the last sound you hear comes back to you first. This challenges our everyday experiences and perceptions of how sound and light work. Another interesting aspect of time reflections is that they cause a frequency shift in the wave. In a normal reflection, the frequency stays the same. However, with time reflections, if red light hits a temporal boundary, it can be reflected as blue light. This change indicates a transformation in frequency, which adds another layer of complexity to the phenomenon. The physics behind this involves a sudden change in the medium's impedance or refractive index. This change creates a temporal boundary instead of a spatial one. Achieving this is technically challenging, especially for high-frequency electromagnetic waves. It requires manipulating the medium's properties faster than the wave's period, which is no small feat. Time reflections are unusual because they challenge our typical understanding of wave behavior and time itself. They do not mean actual time travel, but they do reverse the evolution of waves in time. This phenomenon has only recently been observed in experiments with electromagnetic waves. The implications of time reflections are exciting. They open up new possibilities for controlling waves in innovative ways. For instance, researchers can manipulate light pulses without changing their spatial direction. This could lead to advancements in communication technologies, allowing for better signal processing by stretching or compressing signals in time. In the realm of weird science, time reflections stand out as a quirky and mind-bending effect. Waves behaving as if they can run backward in time defy our everyday intuition. This makes time reflections a captivating example of unusual physics with strange experimental setups and unexpected outcomes. The potential applications in optics and signal processing are just beginning to be explored, making this topic a thrilling area of study for scientists and curious minds alike.